All right, welcome back, my mathletes. That's right, Miss Muscarella coming at you with part two of a three-part series. It's a trilogy on parallel and perpendicular lines. So let's go, let's go. Now, we kind of reviewed a little bit of what given slopes and parallel and perpendicular slopes, what those would all be like numerically. So let's check out example number one here, shall we? I think we shall. So let's take a look. We got standard form equation through the line, negative 4, 7, and parallel to the line, y equals 1 half x minus 7. So this is where we got to do some analysis here. So one thing they're saying is write the standard form of the equations. We know we want that to be ax plus by equals c. And remember, that a term has got to be positive, and it's got to be, can't be a fraction, it's got to be an integer. Right? So no decimals, no fractions. And it doesn't matter the sign of anything else, only a. And that has to be the first term, is going to be your term with the x. Now, when I analyze this, it's got to go through this point. So this guy right here, this negative 4, 7, so that is my given that it has to go through. And it also has to be parallel to this line y equals 1 half x minus 7. So if I know my slope of the line is 1 half, then that means my parallel slope would be the same thing. So my parallel slope would be the same thing. That'd be 1 half also. So check this out. I have two things here, right? I've got a point and I have a slope. So anytime you have a point and a slope, the way we're going to start this off, anytime we're always going to start out by writing the point slope form. So y minus y1 is going to be the slope times x minus x1. Now this may not be the form of the line that they want us to write it in, but we're always going to start that because we have the right two ingredients. We got a point and a slope. Boom, point slope form. Let's go. So we will substitute in the negative 4 and the 7 for the x1 and y1 values, and the perpendicular slope, or the parallel slope, is what's going to go in for the n. So we're going to start off with y minus 7 equals perpendicular slope is 1 half, and then x, be careful here, it's going to be plus 4. So x plus 4. Now the equation that I have written right now, it's in point slope form. I don't want it in that, I want it in standard form. So I got to do a little bit of arithmetic here to go ahead and do that. So if you think you got it, go ahead, cruise through that, hit pause, and then come on back, see if you're good. But for those of us that are going to do it together, let's go. So we'd start by multiplying by 2 each term. So 2 times y, that's going to give us 2y. And then 2 times minus 7 is going to give us minus 14. Now, when you multiply 2 by 1 half, you're just going to, the 2's are going to cancel out, right? So you got to be careful there. That's just going to be a 1 in front. And then that x plus 4 would drop down. But here's where you got to be, you can skip this step here if you want. If you just have a 1 in the front, when you multiply those two, you can actually just go ahead and skip this step and go to 2y minus 14 equals, and then just x plus 4. If there was a number in front of the x plus 4 like a 2, then you distribute and you go about it that way. So we're good. Now from here, remember we got to keep moving. We got to get that x over the other side. So if we subtract, we'll have negative x and plus 2y equals, if I add 14 to the other side, 4 plus 14 gives me 18. Now again, you got to be careful. First term, the ax term, that has to be positive. And I look at this guy right here, it's not positive. So when that's the case, we got to multiply everything through by negative 1 or switch sides. So x minus 2y equals negative 18 will be the final answer in standard form of the equation of the line. That goes through negative 4, 7 and is parallel to the line that we were given. That's it. Pretty straightforward stuff. So take your time when you substitute and then make sure you got to get the correct slope when you substitute and substitute the xy values for your point in there correctly. All right, now let's take a look at a second example here. Let's take a look at a second example. So now in this one, same idea, but this time we're going to go through a line that's perpendicular. So the slope that I'm given, right, is going to be this piece right here. My given slope is negative 2/3. But our perpendicular slope, so the upside down t, that means perpendicular. So the perpendicular slope would be the opposite sign, so I know it's going to be positive, and then I flip the fraction, so that would become 3/2. Then I would start with that same process all over again. I'd substitute in and take my time and distribute and go through all that. So you can go ahead and hit pause because I think you'll be okay with the rest of it. We have y minus y1 equals m times x minus x1, and I think you know what to do. So go ahead and hit pause and then come back and check it out and let's see how you did. All right, so how do we deal with that? Because remember, slope-intercept form, right? That's going to be y equals mx plus b. We've got to get it in that form. Now we'll start off same way we always do, multiply everything through by 2. But here's what's a little bit different. We're not going to go to standard form on this. When we get down to, after we distribute, when we get down here to this line, 2y minus 16 equals 3x plus 6, we're just going to take this minus 16 and move that over to the other side. From there, when we end up with that 2y equals 3x plus 22, I'll just rewrite that over here a little bit. We're going to then divide everything by 2. So we're going to start by dividing everything by 2. And then we can, of course, and some of you can probably do this step in your head. So this 22 over 2, we know that's going to reduce all the way down to 11. So the equation of the line in that slope-intercept form would be y equals 3x over 2 plus 11. All right, so that's it. Those are just two examples there for you real quickly. So take your time. The arithmetic is where most people have a challenge. So just really take your time and use Desmos to check yourself too if you want to, because that's always an option for you. All right, that's the end of part 2. We got one more part 3, with the special cases of horizontal and vertical lines. All right, so make sure you come back and watch that. I'll catch up with you guys in a little bit. Peace.